What we're going to do with this substitution is we are going to plug it in to equation 2. So look at this. We rearranged equation 1. That means we must plug it into equation 2. So this sub will get plugged into equation 2 for the variable x. So that's our next step. Okay. So our next step is I'm going to say plug x, our sub, into equation 2. And I'll rewrite equation 2 first. It's 3x plus y equal to 1. And now all I'm going to do is take this substitution and plug it in for that variable of x into equation 2. So here's what it's going to look like. 3 times negative 17 plus 4y plus y equal to 1. So that's all we did here. We took whatever x is equal to, which is negative 17 plus 4y, and you're plugging it in for x. So here, I'll show that. Boom, there's that. Or maybe shorter. There we go. Okay, so now all we have to do here is solve for y. So we're going to distribute that 3. So 3 times negative 17, what is that? Negative 51 plus 3 times 4y, we'll get 12y plus the y that's out here equal to 1. Okay, so we distribute the 3, and now we'll add our like terms up, and our like terms here are the 12y and the y. And running out of room, but we'll make it. And I'll get negative 51 plus 13y equal to 1. All right, let me make this a little smaller. Oops. Okay, excellent. So I just made more room here. And now we're going to solve for y. So I'm going to add that 51 over. I'll say add 51, add 51, and we'll get 13y equals 52. Okay, and hopefully, if it's nice enough, does 13 go into 52 nicely? Because now we're going to divide by 13.
4 times.
4 times. Perfect. So we get a part of our solution. We get y is equal to 4. Okay. And now we're almost there. All we have left to do now is solve for x using our substitution. So what we're going to do is take this y and plug it into the substitution that we made previously for x. So that's what we're going to do next. So I'll just call this solve for x. And we use the sub. I'll rewrite it. X equals negative 17 plus 4y. And now, again, I'm going to take this y value of 4 and plug it in for that y. So we will get x equals negative 17 plus 4, and I'll put it in a different color, 4 times 4 and just simplify. Oh, that should be negative. And we're going to get x equals negative 17 plus 16, and x is going to equal negative 1. All right. So now we found our x value, we have our y value, and the way to write our final answer is we're going to say our solution to the system of equations is the coordinate point negative 1, comma 4. That's our solution. All right. And that is substitution method. Maybe I should label these steps, right? Step 1, step 2, and then there's step 3, and here's step 4. Okay. Any questions on that process?
Not so far.
Okay, and like I said, there's no wrong way to go about these. If you rearrange equation 1, you have to plug it into equation 2. If you rearrange equation 2, you have to plug it into equation 1. Do not plug an equation into itself because you will get nowhere. Okay, so second example is there on the right. I'm going to give you guys about 5 minutes, try it on your own, see where you get to. And it's always good just to label our equations. There's equation 1, there's equation 2. So go ahead and try that on your own for a bit. And if you have questions on the first one, let me know. Okay, if you're still working, cool. I finished. I just wanted to show you a different route. I started with equation 2, rearranged it for y, plugged it into equation 1. If you started with equation 1 and plugged it into equation 2, again, that is totally fine. There's no wrong way about it as long as we come at the same answer. And my solution I got is -1, 4. So if you have any questions, please ask on that. Let me see. Checking something. Okay. Okay. All right. Any questions on this one? This is substitution method. So any questions on this before moving on? Everybody good?
Yes, sir.
Okay. So let's move on from substitution method and let's get into the next method, elimination method, which is going to be a lot faster than substitution. So again, a bunch of steps we could go over, but I'm just going to walk through it with you. So here we are in example 3. We are going to use elimination method. Okay. And once again, I'll label them equation 1 and equation 2. Okay. So with the elimination method, you, the student, are given a lot of power. And what I mean by that is for elimination method, you're going to choose equation 1 or equation 2, or maybe you're going to choose both equations. And what you're going to do is you're going to multiply them by a number, any multiple, to help you get rid of a variable. So one of the most important parts of elimination method is you should start out first by saying what variable you want to get rid of. So for this example 3, this one is set up nicely for us where we don't really have to manipulate much. So what I'm going to do is rewrite these equations on the outside again. So I'm going to rewrite equation 1, 2x plus y equal to 2. And I'm going to rewrite equation 2 out here. 3x minus y equal to -7. And the way elimination method works says, well, hey, if I add these two equations together, will it eliminate a variable? So for this example, like I said, it's nicely set up. What variable is going to eliminate when I add these two equations together? So there's a positive y there and a negative y. So y plus negative y is going to give me what?
0.
0. Good. So this means when we add these two equations together, my y's will cancel, and I'm going to add up these x's. So I'm going to get this new equation, 5x equal to, and you're going to add up the numbers on the outside as well. 2 plus -7 gives me -5. And all we have to do here is divide by 5, divide by 5, and look at this. X is equal to -1. And now all we have to do is solve for y. So now, since we're using elimination method, what I do with this x is I get two choices. I get to take this x, and in order to solve for y, I get to plug it into equation 1, or I get to plug it into equation 2. And no matter what, you'll get the same answer.
So if it wasn't already ready to eliminate like that and you had to multiply, you don't have to multiply both equations. You can just multiply one of them.
Exactly. You can do one or you can do both.
Could you do both by different numbers, multiply them by different numbers?
Yeah. Like I'm saying, this elimination method gives you guys a lot of power. So you have to understand how to use it, right? How to manipulate with it. So when we get to example 4, it's going to be definitely a lot different. But for now, let's go ahead and finish example 3 up. So once again, once we have x, we solve for y, and you can take this x value and plug it into an equation, of your choosing. Doesn't matter, you're going to get the same result no matter which equation you plug it into. So I'll just say plug x into, it looks like equation 1 looks easier. So let's do that. I'll say plug x into equation 1. And I'll rewrite equation 1 again. 2x plus y equal to 2. And I'm going to plug in that x value of -1. And all we have to do here is solve for y. So this will become -2 plus y equal to 2. Add that 2 over. Let's say add 2, add 2. And we get y is equal to 4. And all we have left to do is write the solution. So our solution is -1, 4. Now I ask you, how much faster was that than using substitution? That was a lot faster than all that mess up there, right? So elimination method is the preferred method, but you can always do substitution. No matter if you use substitution or elimination, you're always going to get the same answer. Okay, any questions on example 3? That was an easy one. It was nicely set up for us. So example 4 is not so nice. Okay. Let's start with example 4. Again, I'll say equation 1, oops, and equation 2. And I'm going to rewrite them out here. Let's say 1, 2x plus 7y equal to -9. And then equation 2, 3x minus 2y equals -1. Okay, and now here is where you're given all the power. The first thing you should ask yourself is, which variable do you want to eliminate? So I'm going to leave it up to you guys. What variable do you want to eliminate, x or y?
Y looks like it'd be easier.
Let's get rid of y. And that's a good choice. And the reason that's a good choice is because one's positive when one's negative already. That's a great setup for you already. Okay, so let's say we're going to eliminate y. This means I need to get rid, or yes, so we're going to get rid of y. This means I need to make these 2 and that 7 into the same number, which means we have to think of a common multiple between 2 and 7. What is the least common multiple between 2 and 7?
14.
14. Good. So if I need to make this 7 into a 14, what am I going to multiply this whole equation by? What number?
2.
Multiply this whole equation by 2. And for the next one, if I'm going to make this 2 into a 14, I need to multiply this whole equation by what number?
7.
7.
So you can always do it just multiplying by each other. It might not be the smallest number to get, though.
Exactly.
Yeah.
All right. So we're going to do our manipulations. And I'm going to rewrite our new equation 1 after the manipulation. So this 2 has to distribute to every single number. So I'm going to get my new equation as 4x plus 14y equal to -18. And my new equation 2, the same thing. Distribute, distribute, distribute.
Especially in the NFC East.
I get 21x minus 14y equal to -7. And remember, now we're still doing elimination method. All we did was manipulate these equations by finding a common multiple in y. And now we're going to add these two equations together. So when I add that 4x and that 21x, I'm going to get 25x. When I add my 14s, my y's are going to cancel. And then when I add -18 minus 7, I get -25. Okay. And then all we have to do is divide by 25. And we're going to get x equals -1.
We have no idea what Brad Holmes, the new general manager, or Dan Campbell, the new head coach, think about Dak Prescott.
Okay. And all we have left to do is solve for y. So we get two choices here. In order to solve for y, we take this x value and you can plug it into equation 1, or you can plug it into equation 2. And once again, it doesn't matter because you're going to get the same answer. We're going to have that off. All right. So we're going to say solve for y. And I'm going to use, I think equation 2 looks easier. So I'm going to use equation 2. I'll rewrite it. 3x minus 2y equals -1. And then I'm going to plug in that value of x is -1 in there. So 3 times -1 minus 2y equal to -1. I'll get -3 minus 2y equal to -1. And then I'm going to add that 3 over. And we'll have -2y equal to 2. And then I'm just divide by -2. And y is going to equal -1. Okay. And the final step is just writing the solution as a coordinate pair. And our solution here is -1, -1. And that's elimination method. That is the fastest way to solve a system of equations. And if you absolutely hate elimination method, well, you can always use the long substitution method. Yes, it may be a long process, but if you understand it better, go ahead and keep using it. Just know that elimination is definitely a lot faster, but you have to know what to manipulate by, what variable you want to get rid of. So whenever you start elimination method, that should be the first question that comes to your mind is, what variable do you want to get rid of? And once you figure out what variable it is, now you have to figure out what you need to manipulate both equations by to get rid of that variable. But any questions over those 2 examples?
So if there's more variables than just 2, could you multiply, then add them, then multiply, then add them to eliminate?
Like if it, like you're saying, if there were like 3 variables or what?
Yeah.
Like x plus y plus z equal to 5 or something?
Yeah.
Yeah. So that gets a little more complicated, but it's still the same process.
You can just repeat the steps.
Exactly. Exactly. But you guys shouldn't get those.
No, I hope I'll never have to do math.
Yeah. You shouldn't get those. This class isn't that crazy. Just a little bit, but not that crazy. I give those types of problems to my actual college algebra class.
Really?
Yeah. But it's a system of 3 with 3 variables. So it looks pretty insane.
But it's just an extra step, basically.
It's an extra step and an extra variable, so you have to go through it all. And then one of the fastest ways to solve these is by using matrices, but we'll learn that next time. But we're not even gonna learn how to solve these by matrices though. The next lesson is like, hey, here's a matrix, let's move on. But I can definitely show you how to work a matrix in a calculator to make things faster.
All right.
Yeah. Actually, since we have time and not a lot of people are here, let's go ahead and check out Desmos for this problem. Because if you're ever having issues trying to solve these systems, you can always check your work. So let me see. I'm going to bring that there. I'm going to bring you here. And let's just use this one as an example. And remember, Desmos has a matrix calculator. So I'm going to click Math Tools, Matrix Calculator. I'm going to click New Matrix, and I'm going to type in the system as I see it. And whenever you type a system into a matrix, you don't include variables. You only include the coefficients. So I'm going to do for the first row 2. I need how many columns? I need 3 columns. So I'm going to do 2, 7, -9, and then 3, -2, and -1. And I think if I hit enter, it might solve it for me. Let's see. Or no, it won't. I just did that. Oh, there we go. If I do RREF of matrix A, so our answer was -1, -1, right? Look how fast this is. If I hit enter, I already did it right there. Look at this. Right there. There's the answer. -1, -1. Instant. It's crazy.
Good old Desmos.
What's up? Oh, good old Desmos. Yeah.
Need to start.
So that's one way you can check your work. Okay, let's keep going. All right, so that was substitution, it's elimination, and then let's get into two more types of systems, like with the end result. So if you're solving a system of equations and you end up with 0 times some number, so 0 times some non-zero number, such as 0 equals 1 or 0 equals 10 or 0 equals -5, then if you're solving this system and you come across something like this, the answer for your system is there's no solution, because these aren't true statements. 0 doesn't equal any other non-zero number. And then the next one, if you come across 0 equals 0, that is the truest statement you can have. 0 equals 0. So if your system of equations zeroes out on both sides, then your answer here is infinitely many solutions. So I give you guys a moment. I want you guys to solve example 7 and example 8 and see what you come out with. And your answers are going to look very similar to what you see in the table above you, but solve them by whatever method you like. If you like elimination, use elimination. If you like substitution, use substitution. But I give you guys some time to go over those. And I will say pick one method and stick with it. All right. So if you're still working, cool. If not, just check your work. Example 7, I came up with 0 equal to 18. And that's definitely not a true statement. Therefore, there's no solution. And then example 8, I got 0 equal to 0, which is a true statement, which means there are infinitely many solutions. Okay, so if you're still working, excellent. If you have any questions on these, please ask away. So give you a couple of minutes to look it over still. But those are systems of equations. So you have two options: solve them by substitution or solve them by elimination. Okay, everybody good with these? Yeah, yeah. All right, let's go then. All right, we come to the last example of the day, which is probably gonna be the longest. Whew. This one is going to incorporate everything we've learned so far. So for this problem, you're gonna have to create a linear equation, giving the information, and then we're gonna have to put them in as a system of equations. And yeah, so there's going to be a lot involved. Everything we learned up to this far. So for example 9, at 53 cents per bushel, the daily supply for wheat is 448 bushels and the daily demand is 591 bushels. When the price is raised to 88 cents per bushel, the daily supply increases to 518 bushels and the daily demand decreases to 416 bushels. Assume that the price supply and price demand equations are linear. Whew. All right. So A says to find the price supply equation. So remember, if we're going to create an equation, we need two ingredients. We need a point and we need a slope. So what this problem is giving us, this paragraph is giving us points to work with. So we're going to find the points, we're going to find the slope, and then we are going to create the equation. Okay. So, and I think when we do this, it wants it in terms of P's and Q's, but when we get there, yeah, when we get there. All right, cool. So I guess before I do that, looking at this problem, wanted the price supply. So let's go ahead and find our points first. And remember that for majority of these problems in this class, price is always Y and the amount is always X. So for the very first point, even if we're looking at for supply, they're giving us that, all right, we have 53 cents per bushel. And for a supply, we have 448 bushels. So we have our first point. So our first point is 448 and 53 cents. There's our first point. Because remember, once again, the amount, bushels represents X. X is always the amount of an item. The 53 cents is Y. Y represents price.
How do we know it's not daily demand?
Because what number is associated with demand? Daily demand is 591. So essentially for this problem, the words match up with the numbers. So daily supply for wheat is 448 and daily demand is 591.
Or I guess what I'm asking is, how do we know that the variable that's controlling the answer is the daily demand and not the daily supply?
Because, well, one of the reasons is the very first one just says we're making a price supply equation. There you go.
All right.
Yeah, good question though. Okay, so there's the first point, and now we have to read the next line. It says when the price is 88 cents per bushel, then the supply increases to 518. There's our second point. Our second point is 518, comma, 88 cents.
And does it matter which of these are X and which of these are Y? Like if we flip those two sets?
It does matter, because then if you flip them, you're going to have a totally different type of graph. Because if you put price first, then you'll have a price amount in terms of supply, but we want a supply in terms of price. So again, like I said, for these problems, majority of the problems in this class, Y is always going to be price. And X will always be the amount.
So typically you're trying to solve for Y.
Exactly. So so now we have these 2 points. So now we're going to have to create an equation, which our equations are always in terms of
Y equals
mx plus b.
Okay.
So this is what we're going for. Okay. And what we know, since we found those 2 points, what can we find between 2 points?
A line.
Well,
slope.
We know that line connects them, but we have to find the slope first. So my slope formula is m equals, and we know the formula hopefully by now. And here's my points, x1, y1, x2, y2. And so we'll have 0.88 minus 0.53 over 518 minus 448. Okay, and let's go ahead and calculate this stuff. All right, 88 cents minus 53 cents. That I think is what, 33 cents? No, 30. What did I do? 0.88 minus 0.53, 0.35 cents over 518 minus 448, 70. And then we're going to go ahead and divide these two. 0.35 divide 70 is 0.005. And this is our slope. Okay. So what's next? Since we have a slope and we have 2 points, we can now find the equation of the line. So that's our next step. We're going to find the equation. And the easiest way to do this is by using the point slope formula. Y minus y1 equal to m times x minus x1. And since everything's neatly labeled as x1, y1, and slope, we're going to plug everything in. Good, Charles?
Yeah, I'm getting there. I'm just the slope and the decimal threw me for a loop.
Gotcha. That 0.005.
And so what is this equation called?
This is going to be the price supply equation. But this, that is the point slope formula. So we saw that last class. Because in the name, it's telling you what you need. You need a point and you need a slope. Distribute that 0.005. And I get 2.24. And then add that 53 cents over. And minus 53 cents or plus 53 cents, $1.71. Okay, so this is our price supply equation, but my math lab likes to put it in terms of P and Q. So we're just going to rewrite this as P equals 0.005 Q minus 1.71. Okay. So like I said, this problem's incorporating everything we learned so far, right? We've learned how to find slope. Now we've learned how to create the equation of a line. So that's what we're doing here, which means we're going to do the same exact thing for step B. So let me erase up here. And now, once again, we're going to create points. So this is for B. And we read the problem all over again. At 53 cents per bushel, now we are making a demand equation. The daily demand is 591. So this is going to be the first point for our demand equation. 591 and 53 cents. And then we read the next line. When the price is raised to 88 cents per bushel, the daily demand decreases to 416. So there's our next point. 416 and 88 cents. We have our points, which means we have 2 points, and we're going to be able to find the slope between these 2 points. M equals the 88 minus the 53 over 416 minus the 591. Okay. So we get 35 above and 416 minus 591 gives me negative 175. And 0.35 over negative 175 gives me 0.002. Okay. And again, same process here. I'm running out of room. It's okay, I can probably write to the right side. So here we go to the equation. Using that point slope formula again. And plug everything in. 53 equal to slope 0.002 times x minus x1, which is 591. And y minus 0.53. Distribute that 0.002. And 0.002 times 591, 1.18. There's a 2 on the end, but I don't think we need it. So 1.18, 0.002 times 591. Okay. Add that over. Minus 0.53, and you get negative 0.65. And again, we need to put it in terms of P and Q. So we're going to just rewrite this as P is 0.02 Q minus 0.65. And this is the price demand. Okay, like I said, a lot of work, right?
Is this what 1.3 homework is kind of dealing with?
This is, well, what was in 1.2 was creating the equation of the line, given the slopes and all that. Yeah. So now this is just a continuation of it, because it's like, hey, you know this now, so let's apply it to further problems.
Yeah.
Yeah. What did I do? Did I forget my negatives? I did forget my negatives, didn't I? Oh boy. That's dangerous. Yeah, this number should have been negative right here.
The slope.
The slope. It's not going to hurt too much. That's going to be positive, and we are instead going to get, what is it? 1.18 plus 0.53.
So 160.
171.
71.
Yeah. Whoops. See? Signs kill, guys. Be careful. Okay. Good catch. There we go. So yeah, and there, negative. It's got to be negative. Okay, that would have been bad if we didn't catch that. Okay, so I think the long process is over for now. So next is find the equilibrium price and equilibrium quantity and round to the nearest cent or nearest bushel. Okay.
So basically where those two lines are going to intercept?
exactly where these two lines intersect. So you can actually set up a system of equations if you want. So we're going to take equation 1, which is P equal to 0.05 Q, and put it over equation 2, which is P equals negative 0.02 Q plus 1.71. So if we put that system together, just make sure everything's right, we are going to go ahead and eliminate P. Let's get rid of P. So to get rid of P, all I have to do is take an equation. Let's say equation 1. I'll zoom in a little more. I'm going to take equation 1 and multiply it by negative 1. And this means that I'm going to get negative P equal to negative 0.005 Q plus 1.71. And below it is going to be P equal to negative 0.002 Q plus 1.71. So all I did was take the first equation, multiply it by negative 1, because now if I add these together, what variable is going to cancel?
1.71.
Well, variable. If I add these p's together, are they gone?
Mm-hmm.
Right? So these p's will cancel, and I'll get
once you keep, you'll be able to do something with the q's.
Exactly.
Yeah.
Exactly. So now you get 0 on the left, and now you can add the q's up, which I'm assuming gives me negative 0.007 Q plus, and your 1.71s actually add. You get 3.42. Let me just make sure my decimal work is right before moving on. Yep. And now all I'm going to do, because now we have to solve for Q. Take this Q, move it to the left side. And we're going to get 0.007 Q positive equal to 3.42. And now just divide by 0.07.
So whenever you're finding the equilibrium price and quantity, you will times one of the equations by negative 1?
Exactly. Because, I mean, if it's P, then we just get rid of the P by making one of them negative.
Check.
And if I do 3.42 divide 0.007 to 2 decimal places, I get that Q is equal to 488.57. And is this want us to round? It says round to the nearest cent and nearest bushel. So 488.57.
489.
489. Good. Okay. And we're almost done. Because all we did was find Q. Now we have to find P. So take 489 and plug it into either equation. So I'm just going to do that up here. Minus 1.71. Bring you back in here. And if I calculate all that, 0.005 times 489 gives me 2.45. And 2.45 minus 1.71 is going to give me 74. So this is our equilibrium price and our equilibrium quantity. So there we go. So at 74 cents, which is our equilibrium price, we're going to have 489 bushels. All right. Whew. Any questions so far?
Need to do a couple of those to get used to that.
Just a lot, right? Because like I said, it's about everything we learned so far. We know how to make the equation of a line. That was the first two questions. We just learned system of equations. That was the third question. That's what we did here for C. We did a system of equations. And now D, it wants us to graph the two equations in the same coordinate system, identify the equilibrium point, supply curve S, demand curve D. Okay, so this is going to be really easy. So we don't have to be really specific about this. We just can do a sketch here. So what I'm going to do is I'm going to draw the graph, and I'm only going to draw, let me see. Do I need the first quadrant? Let me see. Maybe. Yeah, why not? Actually, here, I'll just draw this lovely little graph here. And all I want you to do is remember what slope does. So on the very first price supply equation, 0.005Q, is that slope positive or negative?
Positive.
Positive. And on a graph, which way do positive slopes go?
Up and to the right.
Up and to the right. So my price supply equation is going to be this. This is my price supply. And then, now for the second equation, the demand equation, right here. Is the slope positive or negative?
Negative.
Negative, which means which way do negative slopes go?
Down and to the right.
Down and to the right. And we're probably going to look something like that. Something like that. We're a little off, but it's okay. All right. And this is my price demand. And basically what we're saying is right where they intersect is what?
Your equilibrium price.
My equilibrium price. So here, I'll just redraw this part just a little bit. I'll say this looks like that. How about that? Sure. Just put that off to a bit. And this point right here is the equilibrium point we found of 489 and 0.74. That's it. We don't have to be perfect about it. But if you really wanted to check out the graph, then once again, we can always use Desmos. So let's see how that would work out. So I'll go back to the graphing calculator. Over here, I'll type in my equation, but in terms of x, 0.005x minus 1.71. And then I'll type in the other one, negative 0.002 x plus 1.71. All right, and then let's see what this looks like. When will you intersect? We said at 489. So let me look over here. Right there. There's our point that we found. 489 and 73 or 74 cents. There it is. If I wanted better restrictions on it, I would say here from 0 to, let's say 500. 0 to 500. And over here, I would say 0 to, let's say 1. There we go. That's going to look great now. Look at that. Now that looks way better than we were looking at. And bam, that's the equilibrium point we found. So, all right. So Desmos can always help you visualize the graph if you can't do it. But I think for your homework, because you have a problem on your homework exactly like this. If you just know how to sketch it and put the equilibrium point, you're going to be okay. But other than that, that is it, guys. That was 4.1. Everything was easy except for that last one, right? But once again, that last problem incorporates everything you have learned so far. There shouldn't be anything new other than terminology. You found the equation of a line by finding its slope and using the point slope formula. We learned that on Tuesday. And then we just learned about system of equations. So we solved for P and Q using elimination method. And then graphing, we should know how to graph. But again, this one didn't have to be perfect. We just needed a sketch. So all good?
For now, until that homework comes up.
Until that homework, just try to follow this problem exactly or just keep